Hi, let me present to you the solution for the exercise I gave you. Let's start with problem or with given in number 1. It's the integral of x cubed plus 8 all over x plus 2 dx. So this one is actually a quotient of two polynomials, but we don't have any formula coming from our basic formulas that can be applied here, right? So what we can do is manipulate on the given fraction. So observe that the numerator is a sum of two cubes, where this could be factorized as a product of a binomial and a trinomial, if you still remember. So since the first term is x cubed and the last term is 8, both are perfect cube. The technique to find the factors would be to get the cube root of the first term, which is x, and then we get the cube root of the last term, which is 2. Since the operation in the given sum of two cubes is plus, the first factor should have a plus sign also in the middle sign. Now, to obtain the other factor, simply square the first term, that is x squared, and then you square the last term, which is 4 positive. Now you multiply the first and the second terms in the first factor, that is 2x. So since we have a plus sign on the first factor, the second term in the other factor should be minus, so as to make sure that the product would be a sum of two cubes. Now the denominator would become x plus 2, or still the same, and then you got dx. So this will simplify the polynomial into x squared minus 2x plus 4 dx. And then you're ready to apply the rules of integration. So integrating the first part will give you x cubed over 3 minus 2x squared over 2 plus 4x plus c. Then we just have to simplify this to the simplest form. So you got x cubed over 3 minus x squared plus 4x plus c. This is now the integral of the given original function, which is x cubed plus 8 all over x plus 2. For item number 2, the given is the integral of the square root of x times x plus 1 square dx. Observe that there are actually three factors present in the given. So the first factor is here, and the other two factors are here. So again, we don't have any basic integration formula that can be applied here, but what we need to do is to simplify the polynomial or the function. So we can rewrite this as the square root of x times the square of a binomial will give you x squared plus 2x plus 2. That is expanded by expanding this part of the factor. Now we can distribute the square root of x to each of the terms inside. So you have the square root of, or simply x squared, square root of x plus 2x square root of x plus 2 square root of x dx. So this is by distribution. Now what we can do is to change the radical or the surd to rational exponent, right? So you have x squared times x raised to 1/2 plus 2x times x raised to 1/2 plus 2x raised to 1/2. Again, we got to simplify. So we'll add this. So this is x raised to 5 over 2, right? And that is 2 plus 1/2. Okay, plus 2. This is 1 here. So 1 plus 1/2 gives you x raised to 3/2. Still plus 2x raised to 1/2. Okay, still with the x, since we have not integrated the function yet. Integrating the function will give us x. What is 5/2 plus 1? It becomes 7 over 2 over 7 over 2, right? Plus 2, x raised to 3/2 plus 1 is what is 3/2 plus 1? 5 over 2. Okay, this is over 5 over 2 plus 2x raised to 1/2 plus 1 is 3/2 over 3/2. Now we have the presence of the constant of integration. Simplify. So you got x raised to 7 over 2, and we just have to rewrite the denominator. So this now becomes 2 over 7. We're getting its reciprocal. Plus, so you got 2. Then the reciprocal of 5 over 2 is 2 over 5. You still have x raised to 5/2 plus 2 times, again, the reciprocal, which is 2/3, x raised to 3/2 plus c. So this will simplify to 2 over 7, x raised to 7 over 2 plus 4 over 5, x raised to 5 over 2 plus 4 over 3, x raised to 3/2 plus c. We're able to get the answer for number 2. You still remember the one you said? Okay, now we'll proceed to number 3 item. It is the integral of the square root of 3x minus 1 over square root of 3x dx. Again, which formula do you think we will need to apply here? I mean, among the basic integration formulas. So the technique that you could apply would be to transform this into rational exponents. So you'll have 3x raised to 1/2 minus, so we'll get the reciprocal, so you'll have a negative exponent when you have the reciprocal, right? So simply you have 3x raised to negative 1/2 dx. Okay, then we're ready to get the integral. So how do you think we will find the integral? Okay, we can actually distribute the exponent first. So it's like integral of 3 raised to 1/2 x raised to 1/2 minus 3 raised to negative 1/2 and x raised to negative 1/2 dx. So these are the constant part of the function. So we just have to integrate this portion, right? So you have 3 raised to 1/2 times the integral, which is x raised to 1/2 plus 1 is 3/2 all over 3/2 minus 3 raised to negative 1/2 times x raised to plus 1 gives you positive 1/2 over 1/2 plus c. Then we need to simplify each. 3 raised to halves, to 1 half is actually square root of 3, right? And then you get this reciprocal. This is 2 over 3 x raised to 3 halves times this one. We can make this positive, right, by getting the reciprocal. So you have minus 1 over square root of 3 times the reciprocal of 1 half each is 2 over 1 times x raised to 1 half plus c. So what we will have here is 2 square root of 3 over 3 x raised to 3 halves minus 2 over square root of 3 x raised to 1 half plus c. We can actually stop here, or you might want to transform this into radical equivalent. If you want to transform them to the radical equivalent, you'll have 2 square root of 3 over 3. This is times square root of x raised to 3 minus 2 over square root of 3 square root of x plus c. And this portion could still be simplified. You can extract the square root of x cubed. So you will have 2 square root of x cubed is x, square root of 3, and then the other x that's left here, over 3. Minus, we could probably write this as negative 2 square root of x over 3 plus c. Okay? So you could actually consider any one of these three as your final answer. Okay, question for number 3 item. Then let's proceed to number 4 item. Okay, square root of 2x minus 3 squared dx. So this is a square of a binomial, so you just have to expand and then get the integral, right? This is 4x squared minus 6 times 2 is 12x plus 9 dx, and you're ready for the integral. So 4x raised to 3 over 3 minus 12x squared over 2 plus 9x plus c. Simplifying, you give, or it will give x cubed, 4x cubed over 3 minus 6x squared plus 9x plus c for the last part. Okay, then the last item, number 5, integral of the square root of x plus square root of a squared dx. Again, it's a square of a binomial. Square the first term, that gives you x. Square the last term, that is a. Multiply the first and the second, that's square root of ax times 2 is 2 square root of ax. Both are plus. Oh, this one is x only, dx. And then we're ready to transform this into this portion into rational exponent. So this is integral of x plus 2 a raised to 1 half x raised to 1 half plus a dx. Okay, so the only variable present in the function is actually x. The other letter a should be treated as a constant. Okay, now we are ready for the integral. This is x squared over 2 plus treat this as constant, so it's like you got 2 square root of a times x raised to 3 halves over 3 halves plus a what's the integral of a? Integral of a constant, okay, that's x plus c. You just have to simplify, so this is x squared over 2 plus your reciprocal is 4 over 3 square root of a x raised to 3 halves plus ax, oh sorry, this should be ax plus c for the last item. Okay, do you have any questions on this solution? None. Okay, I'd like you to study the solutions provided and be ready for a unscheduled exam, okay?